Hey folks, first, great job making the decision to click on this video, doing the right thing there. Also, just want to congratulate you on making it to pass the midterm of this class. That's a feat in and of itself, okay? I know that the semester is very long and it can become difficult, but you've done a great job. If there's anything that you're worried about from the midterm or anything like that, please never hesitate to reach out to your instructor or myself. Uh, we'll speak with you, set a plan moving forward, okay? So today we're starting module 4. It's all going to be about a lot of these first couple of video lectures are about exponents. So I want to revisit what we've talked about before and build off of that, okay? So our video lecture 11, first, let's explore kind of that relationship of an exponent and what an exponent means, okay? So I'm going to, like, we know that like 2 to the first, right? 2 to the first, an exponent means repeated multiplication. So it's saying we have just one of these 2, which is our base. So we just have a 2, right? And as we climb in power, 2 squared means 2 times 2. 2 to the third means that we're going to have 3 2's repeated in multiplication. And so on and so forth, right? And 2 to the fifth would be 32. Okay. So as we climbed, right, each time, what is happening to our number over here as we go up? Right, we're multiplying by 2. Okay. This is the one that this is what we're familiar with. And we grow as we have these exponents get larger and larger and larger. But what we're going to explore today is kind of the full range of exponents. Can we move down now, right? What would happen, right? What would we need to do to go from 32 to 16, from 16 to 8, 8 to 4, 4 to 2? What's happening each time as we go down? So we're dividing each time, yeah? Let's move down one more, right? If I wanted to move down one more, so that would be 2 to the 0 power. What would I need to do to this 2 to get down there, right? What's our pattern? We would divide by 2, and 2 divided by 2 is 1. We're going to revisit this here in a moment. This is a big one. This is something potentially new. Okay, let's keep going. We've never talked about negative exponents either, so let's go down one more. So if we do 2 to the negative 1, let's continue our pattern, right? What would we need to do to move down one more spot? We need to keep dividing by 2. So we've got a 1, and we're going to divide it by 2. 1 divided by 2 is half. Let's keep moving down. 2 to the negative 2. If we take 1/2 and we divide it by 2, if we take a half and cut it in half, we get a 4th. Let's keep going just to show the pattern. We cut a 4th in half, we get an 1/8. We cut an 1/8 in half, we get a 16th. Okay. So I need you to think for a moment, what is happening with these negative exponents? Do you see any sort of pattern that enables you to kind of speak about what negative exponents mean, how you'd be able to use them? Okay. So some of you may have noticed, right? Like if I specifically look at 2 to the 4th power. So 2 to the 4th power is 16. 2 to the negative 4th power is 1/16. Okay. 2 to the 3rd is an 8. 2 to the negative 3rd is 1/8. So where these positive exponents kind of represent repeated multiplication, as we move down, right, we were dividing each time. So a negative exponent is representing this or this repeated division. So we end up with fractions, 1 divided by 2, 1 divided by 4, 1 divided by 8 of our kind of original numbers that we came up with there, okay? Again, as we're taking notes on this, you've got section 2, you've got section 3, make sure you're writing something about negative exponents here, Okay, so negative exponents, I would love for people to think about this in terms of repeated division. Okay. All right. And then let's go back to this other spot that we had. We had 2 to the 0 power is a 1. So this would actually hold true for any base that we put there. If I was doing tens, right? 10 to the first, 10 to the second, 10 to the third, whatever it happens to be. As we make that move downward to 10 to the 0 power, we would divide by 10, and 10 divided by 10 gives me a 1 every single time. So anything, this is called the 0 exponent property. Anything to the 0 power is equal to the number 1. Okay. I want to kind of formalize what we wrote up there as well with this negative exponent. So negative exponent, if I have a base a and it is to the negative x power, that is the same thing as 1 divided by a to the positive x power. Okay, and we kind of saw that up here, right? 2 to the third was an 8, 2 to the negative third is 1 over 8. So it didn't become a negative 8, it's still an 8, but it means let's divide by that 8 instead of multiplying by that 8, okay? So those are our two properties that we're going to be using in future videos. So anytime you see something to the 0 power that is equal to the number 1, those are equivalent. And anytime we see a negative exponent, that really means let's divide by this thing. We need to do the inverse rather than what a positive exponent represents. Okay. All right. Great job. Come back for the next one. I'll see you soon.